Welcome everyone. This is the IPLD sync meeting. It's November the 23rd, 2020. And as every week, we go over the stuff that we've worked on the past week and then discuss any open items we might have. And yeah, I start with myself. I actually can't recall what I've worked on last week. It must have been more, but I can only recall that my biggest successes are that finally the PRs emerged. So libp2p is now using the latest Rust multi-hash, and Forest, the Rust Filecoin implementation, is using the latest Rust multi-hash and Rust CID. And so the good news is I've talked to the people from Forest that the performance, like they couldn't really measure a difference, but they could at least measure that is, so the quote is strictly better performance. So it's certainly not worse. It's definitely better, but it's probably not measurable, but still there. No regression there. So that's great. Good to know. And probably also like the libp2p folks would have said something if there would be a regression. So that's good. Yeah, that's pretty much it. Next on my list is Danielle.
Cool. So last week, I basically finished the multi-codec library the week before, but this is just an FYI that I plan on tagging the first post rewrite release tomorrow. So if anybody has any last feedback, please speak now. And I did polish up the names a little bit last Monday. So now the names are a little bit more idiomatic Go, and the code generator is also smaller, which is nice. I also spoke to Rod about, well, this is coming from what Michael said the week before, which is it would be nice if the hemmed ADL also supported the Filecoin hemmed, because we've got a lot of data in that format. So I spoke to Rod about like exactly what are the differences between the two schemas and how important it is to support the old one versus the new one, because supporting the old one is useful today because we've got a lot of data in that. So the actual difference is only in the element type, because the new one is kinded and the old one is keyed. I think I got that right. So Michael actually came up with an idea to just make like a double union, he called it. So there's an agenda item about this later, so we can take a look at that. And I also spoke to Will about potentially using this instead of the Filecoin hemmed ADL in his stuff, because right now I believe he uses that with an IPLD prime node wrapper, which is like read-only for doing things like selectors and stuff. So I think I'm pretty close, because I've got most of the stuff I need to read existing nodes. I'm just missing, because the prototype is there and a bunch of stuff is there, I think I'm just missing reify and maybe some other bits like caching of link loading. But most things should be there, I think. I also gave a talk about Go's build cache, which went pretty well. There's a video up if anybody wants to watch that. And I'm giving a talk tomorrow about init time tracing in Go 1.16, which is pretty niche. But if anybody has super large Go binaries that take a long time to start, those are all the init functions doing work. And with 1.16, you can actually measure how long they take per package, which is really nice. And the last thing, it's something that's been going on for a bunch of months. I've brought it up, I think, once or twice before, but we're kind of redesigning the encoding JSON package into like a version 2, but it's not public yet because we don't know if it's going to be a version 2. Maybe the experiment is going to fail horribly. It probably will. But I can share some details later if anybody's interested. And that's it for me.
Thanks. This actually reminded me what I did last week. I was speaking at a virtual meetup and I prepared almost all week the talk. That was it. There will be a recording. So there's no recording now, but there will be a recording published sometime. Yeah. So next on my list is Rod.
A similar week, Volker. Yeah. It's been a lot of the week actually on slides for Michael's chunking tree presentation. Which I think most of you probably haven't seen, but I think because I've spent some time trying to understand the algorithm and then figuring out how to explain it in a way that would help me if I was just looking at slides to understand it. So I think those slides are pretty good at getting to the core of the algorithm, and so they're probably worth sharing at some point. So I think there's still just a little bit of the security case, like the collision case, that needs to be sorted out. That's really a fundamental problem that needs to have a solid solution before we can trumpet this thing loud and wide. And that continues to bother me. And I know Michael thinks he's got solutions for that, but we'll talk about that in one-on-one, I think, Michael. Anyway, that actually took up a couple of days to do that. I've been messing around with River's S3 data, Filecoin data. I made a local block store that could store it efficiently enough, just using car files and LevelDB for indexing. I know, and Michael's working on a block store as well, so we've got multiple block storage things going on, and Will's got car indexing stuff. So there's lots of block store stuff happening here at the moment. So lots of interesting things. But I'm hitting all the problems associated with traversing very large graphs, and that's, you know. So anyway, I don't want to get stuck too much in this stuff, but I really would like to have easier access to this data, and then spend a little bit of time on clarifying terminology around the Filecoin Genesis block, which is a bit of a mess. But I think I've got a final form in a PR that I'll merge today in the specs repo, just because there's a Genesis and then there's a Genesis in Filecoin, and these two things need to be described in our docs because one's different to the other. And so trying to extrapolate from Lotus code how people think and talk about this thing didn't go as well as I hoped, and it required some intervention from various people to clarify the issues around it. Anyway, I think the PR is good enough as it is to clarify that language and the situation. So that's all I'll say about that. That's really all the notable things for me this last week that I can remember.
Next one is Will.
Sure. So the GraphQL thing on top of Filecoin is up on a public address and running, and people are using it, which means there's bugs and feature requests and so forth. There's a couple places where I'm continuing to tweak things. One of the interesting ones is the natural, like, base type that GraphQL exposes as a scalar is called ID. And it is very natural for us to say our CIDs are that ID type. But since that is a built-in GraphQL type, that means you do not get to easily override anything about that type because it's built into the GraphQL library. And for instance, that means you can't then define how to pretty print CIDs in their string form while holding them in their byte form. Right, so we have our IDs in actually a sort of non-standard type. And so we would like to think of this as that core GraphQL type of a ID scalar in some sense, but also we have some custom rules. So that's one place where, yeah, we're gonna have to figure out a path. It is doing a sort of icky partial loading of HAMPs, which helps speed quite a bit. There's a couple PRs in Go IPLD Prime, one that was minor that's merged, another one that's has the code generation look at the destination package that it is generating code into and skipping generation of types if they're already defined in that destination package somewhere not in auto-generated code, as a way to just let you take a type and define it with some weird custom things and not have, and then also code gen the other things that aren't there. There's probably a way to code gen to like expose some sort of methods that you can put in as your overrides that is narrower and more tailored to the sorts of things that actually make sense. And I have not figured out how to do that yet. The other interesting thing of note to this group maybe is I added another cache that seems to be pretty effective at the speed, and that is a realized object cache. So this GraphQL server keeps a in-memory thing of CID to IPLD.node of the parsed things. So rather than going back to the data store, it reuses those nodes that it has parsed and realized. And that seems quite useful and a layer that we should have a cache for. That is quite simple, right? Like that's just, you do an LRU or an AMT, or you make some cache when you do it. The only place where it was annoying because of my other hacks that I've been doing, because Lotus on its state roots, sometimes until the upgrade of V2 actors, it didn't have a layer of indirection at state roots. So it just directly, the state root pointed to the hamped of actors instead of this now defined state root object, which is a SID of the hamped of actors and a version ID. And the way that I unified that previously is if I failed to parse it as the struct that had the hamped of actors and the version ID, I made one up saying it was version 0 and then put the same SID as the hamped of actors because it was the hamped of actors. But now that means there's 2 IPLD nodes with the same CID in that case. So I am keying on both the CID and the type of the IPLD node because I do know what that type is going to be. So my keys are uglier than they need to be, ideally. And that's sort of my fault and my misuse of CIDs in some sense. And I'm sure people will feel strongly and unhappy at me for that choice, but that's where we are. Yeah.
I have a quick question because you wrote IPLDQL. Is this the actual name, or
I have sometimes called it that, yes.
Because like
that was my goal for what the so StateQL is like the Filecoin applied version, but the generic cogen of a GraphQL server over IPLD data, right? Because there's sort of 2 layers here. There's the one that's totally generic to an IPLD DAG, and then there's or schema, and then there's the one that is the Filecoin specific binary server thing.
So I would be super happy if we would keep IPLDQL for in case we come up with a query language or something, and
okay,
just call it, I don't know,
sure.
like IPLD.
Doesn't exactly roll off the tongue.
But like it's like it might be just me, like if others like yeah.
I would plus one this.
But
I think it would make sense to shove a G in there or something too.
Yeah.
Sure.
But yeah, so just having worked on query languages.
It actually is easier to say with the G. I feel like.
Yeah.
Like that D to Q is like a weird transition for my tongue to make.
Yeah. Okay. Sorry, I totally. Who's next? Eric is next.
So that, yeah, sorry, I'm still trying to not laugh at the pronunciation of that. So there's a recording from last week. I was also in the ranks of people giving talks. And so there's a What's New in IPLD talk that was recorded as part of the IPFS meetup last week. And there's a link to where that exists on YouTube. My section is like only 10 minutes of that. So if you want a really brief overview of what's up and what's new, it's about as brief as it gets. There's a lot of other stuff in that video, but I made a link there with the time offset too. In GoIPLD prime code, there are a couple of small things merged. For example, the cogen output rearrangement. So finally, cogen will output a finite number of files instead of a file for every type, which was operationally annoying. So fixed. I was doing some discussions with Will, as he already mentioned, about how we might integrate ADL stuff in practice. And I think it seems like we're probably going to do some present tense shortcuts, which are aimed towards letting people do arbitrary weird stuff. And then that'll let Will do what he wants. And then there'll be a rather distinct roadmap for like how we want to integrate ADLs well in the long term. And that's going to be we're going to take that one slower. The present tense shortcut is probably going to be something that's unique to cogen and just like really it will assume that a human is very much in the loop. So it's going to be, it'll be safety's off sort of scenario. And we'll see how that goes. And other than that, a lot of this week seemed to disappear for me too. Working on a lot of planning and scoping docs and just plain thoughts for the future. So more docs about that will probably come out later. And that's about it this week.
Thanks. Next one is Peter.
Yes, so a lot of glue work again this week. Stuff that is interesting for IPLD, aside for, you know, Falcon plus Dumbo Drop, Space Race 2, stuff that's not very interesting. We hooked up Will's front end to not yet complete and somewhat unstable version of an SQL-based data store that has like everything in it, including state, including receipts, well, supposedly everything. And it is currently served, and a lot of people are already using it. And speaking of naming, I like to call this GraphQL because it rolls off the tongue very nicely. Yeah, that was interesting to get running on a very short notice, because the Red team really needed that. Another thing that was done a lot was moving around various versions of the data store for various purposes, solidifying a little bit more what actually needs to happen for this to be you know, available at least for our IPLD needs going forward. And I hope by next week I'll be able to talk about this more in detail, but for now everything is still very much in the air, and it's just really really difficult to navigate through all of this when everything you try takes like an hour and a half. So yeah, but welcome to Big Chain. And yeah, that's pretty much all I have this week.
Thanks. Next one is Michael.
Hey, so yeah, I had some more calibration stuff last week, and then more doing 2021 planning still. Got to get that ready this week. And then, yeah, I did a bunch more work on CADB, got it working and benchmarking. It looks great. It's really fast. Code's a mess though. I just like hadn't really implemented these trees much. And then, yeah, it just, things got like wildly out of hand. And so it's working really well, but there are some bugs, and hunting them down has just been so painful with the way that it's written. So I'm looking at, as I was looking at kind of like breaking it apart and putting some better kind of abstract layers in there, I realized that there's just a much more abstract version of these trees that I could implement, and then use that implementation of those trees to do this database or any other data structures. So I started poking at that a little bit, seeing what that's like. The caching layer you're talking about was funny. I have one of these caching layers already in CADB, and then now I'm porting it over to this other one. And the funny thing about it is like, I'm actually making the addresses of the nodes sort of abstract, because in CADB, those are just integers for the file offset. And then like in the other Merkle structures, like they're obviously going to be CIDs. So I just wanted to make that a little bit flexible. But yeah, it's like you want to make any of this stuff fast, you end up needing a node cache where like the fully materialized node is already there. Yeah, and then that's most of what I got done.
Thanks. Next one is Chris.
Just continue work on JS graph sync request validation. That's it.
Thanks. All right. So today we have agenda items, starting with the first one from whoever. I think it's from Daniel, I guess.
Well, it's Michael's pull request. I don't know if you want to talk about it.
Okay.
Yeah, I don't know how well this sort of double union thing works. I'm actually looking to Eric and Rod to tell me if that's reasonable or not. Should work. I mean, theoretically, it should work. Yeah. But yeah, it also, Rod, it includes that change that we had talked about a little bit, that just makes the root hamped reference a link instead of being in line. You're muted. I can't hear you.
Just looking, this is a pull request against the specs repo, is it?
Yeah. It should be the latest one. It's an incomplete PR in that if you did want to merge this, we'd want to change the Filecoin section at the bottom. But I just really wanted to talk about the schema change. But this should allow us to have both, to support both hands.
I mean, why is this a theoretical question? Don't we have enough tooling to just try that already, to just see what's going to happen?
Probably. I mean, I wrote it like this afternoon. So
the thing that I see as interesting about this is the semantics that come out of this is that you would be able to intermingle both structures in the same tree. And I don't know if that is desirable or intentional.
Well, the implementation wouldn't really allow mixing them. It's just that, well, at least for my use case, there would be an API entry point that says use the old stuff, another one that says use the new stuff. And then depending on that, I follow one path or the other. Does that make sense?
But loading them, it would. I think what Eric's saying is if you load, you could then load mixed crazy data.
Then I reject it later.
Do you have enough information at that point to?
When you instantiate it, you could say what type it needs to be in.
It's just shifting a bunch of checks from being done for you by the schemas to you have to do them in your application level logic for this, which is always something that you can do. It's just should questions.
Yeah,
it moves one check, I think.
So here's the thing. This is fine, except it'd be nice not to do that in the formal spec. Like maybe this could be something that could be, here's how you can combine both of them. You know, it's the why not both thing. Because that, you know, the keyed union is so horrible. Like I don't really want to bake the keyed union into our ideal spec.
Yeah.
That
so
thing
I feel you on that.
Because of miscommunications and accidents. Like nobody wants it. I don't think it. So plus one, our ideal spec.
So I mean, the reason this came up is just that we could have a schema that Daniel could use for code gen and implement both in one. Yeah. And so I think that it does get us there. I would like to take.
Cool.
Right. Yeah, I would like to take the linking the root node change. I don't know how you feel about that, Rod.
I'm not that keen on it, but it does, you know, I don't know, it's fine. I hate these tiny blocks. Like that's a tiny block.
Yeah, but you only have to create it when you want to reference somebody else's.
No, you have to, but you have to create a new one every mutation. So you've got the two nodes at the root need to change it every mutation.
Yeah. I mean, that's not the most annoying tiniest block that I create. Like, oh no, what was I going to say? Oh yeah, so maybe like this could move down to the bottom, and we could basically have a schema for the unified thing at the bottom instead of just like the one-off for Filecoin. If we're going to use this to.
Yeah, although that particular change of linking from the root.
Yeah, that would need
an ununified one. And unless we make that a union, you make that a union for a kind of union for a link or a list.
Right.
Could do that.
Yeah,
too.
we could put that in the main spec, the kind of union. Yeah, that makes sense. Yeah, you should be able to inline it. That seems reasonable.
I know this question of of linking to the root node and keeping your configuration out into an external thing. I'm not totally sold on that, except in the case where the root node is interchangeable with other nodes of the graph, like in the vector spec. You can pull out any arbitrary node and make it the root node. And that's a nice pattern where you could, if you had your configuration that was a bit more advanced, you could have that separate so you could link it down. But with the HAMP, it's like, it doesn't work that way.
Right. But the another thing to think about too is that it's not a given that those settings and that data go into a unique block. There's no guarantee that that schema is being applied in a unique block. That could actually be embedded into a different schema, and it could be inline. Do you see what I'm saying?
No.
So the whole root node there could be inlined in a different structure. You could just take this schema and use the value data inline. And there you actually may want to say like, oh no, I actually want to be linking out here because, yeah, and because it's not a big deal. You're not creating tiny node or tiny blocks at that point to do on every mutation. You were already going to have to relink it in. Yeah, I think I do that in DagDB actually, if I'm not mistaken.
There's so many variables. It's very difficult to say one thing is objectively worse than another. But I think we know that the size of CIDs is really costing Filecoin because they're explicitly storing everything. And so once you push towards smaller blocks, then the size of CIDs becomes a real problem. Which, I mean, it's not, I don't want to derail this particular question, but there is this thing that came up in, was it the meeting we had on Thursday? No, it was a different one. Maybe it was last week's meeting, just about, because Filecoin stores everything explicitly, it takes up so much space, whereas other blockchains, they're okay with implicit structures that you can recalculate on the fly. And this goes back directly to the nature of IPLD itself, where we are explicit. Every block exists as a thing, and they're very concrete with regard to CIDs and navigation. And this it's a more fundamental critique of IPLD, that if you remove the space where you can't be implicit for really simple constructions, and just say, look, they exist, and you can recalculate them whenever you want if you've got all the data. It ends up costing us really badly, and we're seeing that in Filecoin. There's a bunch of places where you could imagine these implicit structures that exist and they're recalculable, and everyone can consensus build them. But because we have all of these blocks laid out on disk, that's huge. Anyway, that's just the thing that I think would be worth us pondering as a collective.
Yes, but also Filecoin is one of the very few chains, pretty much the only chain I can think of, where you can literally start from a state root and get everything else from somewhere else and be assured that the entire thing is correct. You basically don't have any of this stuff that you are fighting in Bitcoin, that, you know, you have pieces of the chain which are not actually encoded into any of the hashes anywhere. They're just, you know, nonsense and stuff like that. We don't have any of that. We have, like, literally, you have the deep set key. It describes the entire, like, multi-terabyte chain to the last bit, which is
but that's the pro of IPLD. But there's no reason you can't combine the two worlds, because the problem with Bitcoin is that they've approached it without this lens of every addressable block is a thing. They're devoid of that lens. They just have this sense of, we need to be able to content address it all or hash it all in some form. Whereas I think we're at a point where the way we view things means that everything can exist, but it doesn't have to exist on disk. So there should be a synthesis of both worlds possible, where you can say these parts are so trivial that they don't need to exist on disk. I don't know what they are. I mean, I can't point to any examples on the Filecoin chain. It's just, and maybe maybe that comes from not acknowledging this and just saying, well, everything has to exist, so therefore we're just going to lay it all out like this. But if you said, well, not everything has to exist, there is these implicit pieces that will exist if you have everything. Yeah, I don't know where that's what's going, but it is definitely a big cost.
Yeah, I believe when we spent a little bit more time actually analyzing the chain and and analyzing the structures from a clean room perspective, kind of what we're doing, we will end up in a situation where it will be like, oh, they actually need all of that. Because if you think about it, what the chain actually does is kind of unprecedented, where every single thing ever existing needs to ping you every 24 hours. Like, that's not something that chains normally do. So yeah. Like take the entire system of vector IDs. It's literally an auto increment primary key, an integer, which when you have a chain reorg is rewritten. So like the entire chain internally points to things by a simple integer, and when you have a reorg, you need to go back, match every single integer from the previous state to a stable address, and rewrite them to the new integers that are now in chain because the state is different, and you go forward with that. So even this kind of stuff, they already shaved as much as they can by basically not using the cryptographic stable addresses. And there are like all these RLE encodings for all the partition populations and stuff like that. So yeah, I'm actually not sure there is much to shave without. Yeah, I don't know. Will actually will know more at this stage. He's the one who most closely had a bird eye view of the entire thing, I guess.
I don't know if we want to spend too much time on this topic. There's a big rabbit hole.
Yeah,
sorry.
I mean, I think we would need to look at deltas. My suspicion is that there are subtrees that always change together, where being able to collapse links would be beneficial to us because they're not referenced other places. But I don't have, I think we need tooling to identify what those places are so that we can be better informed about how to structure things. I don't think we just know that offhand.
Yeah, I think.
Okay, so this, I'll back to the HAMT question. Okay, so the linking from the root to the root, the config to the root, let's call it. It's not. I'm not a huge fan of it, but it does help us to support Filecoin, with that additional schema change, and it does also just open the door for use cases where people will show up and say, I don't want to store the configuration with the data. I have that in my code, which I think is a legitimate request, which Filecoin has and others will have. So maybe that's reason enough to do that.
You want to change it completely, or you want to do the union?
I don't know, but I'd probably be okay with just the link. It's just my sense of tiny blocks having to mutate constantly with massive CIDs.
Again, like a lot of times, like it's not, you're not creating anything extra. It's just, you're just moving where the link is because the other data is getting inlined above.
Okay. Maybe, I don't know. Well, let's take it to GitHub.
Like yes. So I don't have a strong opinion, but like a union sounds like best of both worlds, because like what you actually do is like you either want to have it implicit as Filecoin, or you want to have it in the block. Basically basically with a union, those two cases are served. And if you, of course, you then could do this thing with like a tiny block, but you probably won't. Like, why would you? So
Michael would.
Michael would. Yes. Okay.
Yeah, maybe that's right. It's just the more we do this, the more we're saying there's room for even more choice. You can do what you like. We're not showing up with here's the best way of doing this thing. That's the ideal. Is like you don't need to make these complex choices because we've made them for you. Because there's so many subtle interactions here that for IPLD to be this thing where you have to understand all of it to make informed choices is not a great place to be. And that's where all these unions are getting us. It's like, well, you could lay it out in this way, or it could be this way, or you could have a combination of both, or maybe this other thing.
I mean, look, the implementations can make these decisions. They're going to have sane defaults, and they're going to default to whatever the author thinks is the sane thing to do, and then they're just going to, support both on read. It's perfectly reasonable.
Yeah,
I don't think that like we need to get this aggressive about making choices in the specs. I do think that the implementations should make some choices though.
No, but
I think the idea that was touched upon earlier of we should write something in the spec that's terse and clean and is what we want, and then shove in a couple of alternative schemas as appendices, which can be any of these implementation choices or even several of them, and just highlight them for contrast. Is like, as an implementer, you might want to do this that does this funny union here because it's really useful in practice for this compatibility reason. I think having several of those documents show up is actually super reasonable.
So what's the actual use case of having like support, like having one schema for both? Like, don't you always, like if you implement it, always implement either of them?
No, so we're literally implementing both. Like that's literally what we're doing, is we're implementing one that's both. So we need the unified schema, at least for that. But it doesn't have to be the main schema. It can just be the bottom.
Yeah. So what I would do in JavaScript is I'd have the front end algorithmic piece and then the back end layout piece. But where we're at with like IPLD Prime is that becomes really tricky because the layout piece is so intertwined with the algorithmic piece. And I think Daniel, you said you could see a path to doing that, but you would end up having to like sub packages, and it would just get messy and awkward. So if there is a way to squish them into one implementation, and then that is kind of ideal.
I think it is theoretically possible, but it gets into, can I don't know what word to use. Can I coerce the code generator enough to like let me do that? And I think that's probably rushing it too much.
Yeah, we don't want to hold them up forever on this when we can just like write a unified schema.
Well, maybe Eric has a good idea of whether or not the code generator is smart enough to support that kind of magic.
No. Long story short, no, not even close. But yeah, I think Volker's question is also really good. Like in pursuing this idea of a unified schema for this particular implementation, I think we are indexing pretty intensely on the costs and the practicalities of this particular Go code generator, where it's relatively high cost to generate tool hole packages with two different schemas. And as long as we're conscious of that, that's a totally fine trade-off to make, but we probably do want to be really conscious of it and document it, because if there was some totally other implementation of schema logic that had different costs than this, we might not be feeling the desire to make these choices at all.
That's a good point. Like the way that I use schemas in JavaScript for validation, like I would actually prefer to just have two schemas and figure out which one to apply and validate differently, right? Yeah, that makes sense. Anyway,
let's leave this one with me, and maybe I'll come up with a bit at the bottom of the document that says, here's alternatives, and this is the way you can craft a schema that supports these alternatives.
Cool. I don't know, we got some time left. Rod, do you want to go over the slides that you made?
Wait, I have one more. Like I have one more.
Oh, you do. Sorry.
Actually,
sorry.
Yeah, no.
Strings, isn't it?
No.
It's actually kind of about strings. Therefore, I want to bring it up. So no, it's like, so I just got today a pull request on DAG, on the JavaScript DAG protocol buffers implementation, kind of like the one that IPFS is using.
Mhm.
And it is actually about, the idea is that links only have bytes which are higher than 31. So basically the control characters. So basically the idea is that in JavaScript, a link strips off any bytes that are control characters of the link name. I hope this makes, if it doesn't make sense. So basically the background is, if you have those characters in and you have a file name with those characters, what can happen on the output, like if you print it somewhere on the terminal or something, you get the control characters could get in your way of everything. And then I briefly discussed this with Alex, whether this should be on the DAG protocol buffers layer, or if it should be, as it is about printing things out, on the printing out layer, basically. And
Or
I just want
Unix
to bring up,
FS.
like, I think it makes sense to, yeah. So Peter wants to say something.
Yeah, I have opinions. Like I saw this this issue just now in the list, and I'm like really angry about it, because like stripping stuff, it's like the only thing you cannot do. Like no other tool does that. I actually have an issue from 3 years ago where I explored exactly this, using control characters to when you do an ls to basically, like, you know, write stuff to the screen that the terminal will interpret. And no other tool actually drops these characters, it just encodes them correctly. ls does the right thing, tar does the right thing, and so on and so forth. And our answer is what? We're just going to drop them. I mean, like, we need to like either escape them or encode them, or, you know, or indicate somehow that there was some more stuff there. Just dropping them is like silly. I don't know.
Okay, so we could also like totally escape them, like, so. And so also it's important, like, so it's really, so it's only, so in this PR on the JavaScript side, it's really about, like, if you get it returned as a JavaScript object. So of course, like for creating the hash and so on, of course you keep the original data around, because, well, you don't want to have the hash changed. But it's just for, if you get back a JavaScript object, they strip off those characters. Yeah.
In what context are they stripping them off? I guess that's what I don't understand. It's like when you call .string on it, or
oh, like if you deserialize the, so you have the serialized the protocol buffers and you deserialize it into JavaScript, then what you see in JavaScript, and you say .name to get the name of the link, it will have those characters stripped off, like just removed. That's what the current PR is doing.
And you cannot round trip them, right? It's removed. Like if you try to encode it back, you are out of luck.
No,
Someone
if you
drop a link
encode
to
them,
this in the
they're-
chat, please.
And so it's on the, it's also in the, wait, yeah, let me post it on the chat as well. It's in the notes on the agenda items. Sorry, the chat is, where is it? So, sorry. So it's this PR. No, so what happens is internally it still keeps it around, so it cleanly round trips. It's just if you access the property, then you don't get it in JavaScript.
So, okay, so basically, if you have the object and you try to encode it, it will like magically put this stuff back. But if you like create a new object with the same content, then you're going to end up with a new.
Yes. Yeah.
So when you're asking for the name, which I guess is sort of the, I want to print out the name, is why you would use that version of it. Why don't we give the base 32 string representation of the SID, which is our standard way that you print this out and have it as human readable?
No, it's not. No, it's not the CAD. It's the name of the link. So basically the name of the file. So
essentially a map key, but in the protobuf like weird way of it.
This needs to be wherever it's being consumed. I don't see why we need to bust our data model. I mean, this package is not pure data model. The new one is JS DAG PB is, and so I definitely wouldn't do this there. But for the same reasons, I wouldn't want to do it here either.
Yeah. So basically, so the answer is they should put it like on the layer higher, whatever this layer is.
Yeah.
Like,
push it as far out as you can go. Like, but because this is a problem in general. This is not just about this one field. Anytime there's a string, then you care about this.
and it's even about like.
I was gonna say, like, no matter how they push it. Sorry, go ahead.
Yeah, so it's even about like strings as like valid UTF-8 strings. So we're not talking. So just as a context, we're not talking about arbitrary bytes. We're talking about like it's a valid UTF-8 strings because it's the first characters of ASCII. So just as context. Okay. So okay. Cool.
IPLD team says no.
Yes.
Well, here's one reason. I mean, you're gonna have to craft a response to this, but one reason is if they want the migrate path to the next generation of the stack, this is just not going to work. It's not going to fly there at all because we're very strict about data model forms as object shapes, being able to round trip and not having any of these special properties. There's no special properties, no hidden properties, no rewriting, nothing of that. It's just what you get is what's there. So you've got to deal with all that junk up the stack if it's a problem to you. We're not going to be patching these minor things all the way down.
Yeah.
Because if you're here's another argument. If you're to round trip this DAG PB data into DAG CBOR for some reason, which you can do, you have the same problem, but now it's in DAG CBOR where you don't have these defined properties in JavaScript. They are just properties that come out of the data. They emerge out of the data, unnamed and unhackable in the code. And so it's a problem for strings in general. They will be there. You've got to deal with them.
Yeah. Okay. Cool. Yeah. So thanks for the input. I will write a response.
Okay. I was going to ask, are you taking to write the response? So yeah.
Yes.
Awesome.
Yeah,
Thank you.
Response. Yeah. Cool. Yeah. That's yeah. Okay. There's nothing else. Okay, so yeah, so we still have time. So, Michael, you wanted to say something?
Oh, I was actually just going to say, like, maybe Rod can show the slides that he wrote. I'd actually like to hear Rod explain it instead of me. see how well the transmission has happened of how these work.
That would mean sharing a window and actually pulling them up on this computer.
They're in Google.
Yeah, they are. Sorry, I did this on my laptop and not on that here. Hang on.
On the Switch accounts and stuff.
I was actually editing the slides while you were presenting them the other day, Michael, because I saw.
Oh, really? That's good to know. I need to copy them into a new presentation soon. So.
Yeah. Okay. Let's do a quick. Let's see if I can do this in 7 minutes. Probably not, but sure. Let's see. Let's share this. Okay. You see that screen?
Mm-hmm.
So, and this is what Michael's been working on with Macola, been hammering it back and forth. Lots of interesting discussion happening there. Macola keeps on surfacing these interesting ideas. But the basic, at the core of this, I think is really interesting to understand. There's just like this one key piece, I think, that if you get that, then you can see what's going on. So here's the problem, right? We're trying to what we really want is a way to store a sorted list of entries. That's like the holy grail for our data structures. Once we have that, we can do so much with that. And maybe there's different variations of what we want out of that. So maybe there's different data structures that will do this for us because we have different utility for them. But really, once we have something that we can store sorted and we can query in a sorted way, to do range queries on, then we can leverage that up to produce all sorts of really interesting tooling on top of this. So right now we have a HAMP as our general purpose data structure that serves so many purposes, but and it's got so many really nice properties, but it's the lack of sorting means that it sort of stops short of being a general purpose data structure. So let's say we've got a list of things here we want to sort. This is the generic problem space. These entries, where they're laid out here just as strings to CIDs, but they could be anything. In fact, they could just be strings in a list, and you want to store a set of strings. That's it. But something that you can run a compare operation on to put them in order. And there's an additional constraint put in here to make this work, which is that they should be unique. And I think that's an okay property to have in general, because you can work around that if you have non-unique items in a number of ways. So the naive solution is obviously to make just a normal tree where you branch with a maximum branching factor. And so in here, we've got a maximum branching factor of 4, which splits our data into 2 and gives us a root node to point to. That works, except mutations become a problem, because if you want to do inserts, then you have this shuffling problem. So an insert will make an overflow that then can impact the whole tree if you do it in the right place. And so you have to rewrite every node if you insert something at the beginning of it. So it's a yucky solution for what we care about. And the same thing with deletes. Make spaces and you have to shuffle everything back up again just to get the canonical form with the maximum branching factor. So really not a pleasant solution. So the idea that Michael and Mikola have been working on is to treat these entries as if they were something that you were putting through a chunking algorithm. And so, that was the piece for me of just viewing these things differently, viewing them essentially as a string of like a string of bytes that you were scanning through and finding some way to slice them up in a predictable manner. So if you scan through this list, where do you find predictable breakpoints that you can always break and turn them into nodes? And you can do that with chunking algorithms. And you can actually do really simple chunking algorithms. So in the form that Mikola was actually using a proper chunking function. So, but Michael just decided, well, we have randomness here in the form of predictable randomness in the form of CID. So if you have well, actually, the CID in this instance you have, but if you just have a hash function for the entry. So if it was just a string and you hash the string, then you could just get an identity from that hash function in some way. So just turn that predictably or stably into a number within a certain range. And so in Michael's current iteration, just take the last 4 bytes, you get a 32-bit integer. Your range is 0 to max uint32. You can then choose a branching factor that will give you a way of slicing these things. So if you divide your index space up into your branching factor, so let's say your branching factor is 4, you divide max uint32 by 4, and then you've got your 4 slots. You just say one of those slots is where we branch. And so if anything falls below the lowest one, then that's a break. So let's take these things, hash them, and turn them into these identities. And then you say our threshold is this lower quarter of the address space, of the identity space. And at that lower quarter, whenever one hits that, then we should break there. And so that gives us a probability of 1 in 4 of hitting a break, which then gives us that branching factor of roughly 4, of approximately 4. So in here, we've got two of these entries have hit the threshold, and so we chunk. So we say, okay, we went along, we read along, we found one that met, so we're going to say this is our branch. So treat these as a close operation for our node, and then you end up slicing your set into a set of nodes based on this close operation. So got one close here and one close here. That's given us 3 nodes. And it seems a bit sloppy, like these things are not exactly the right size. And that's true. They flex in and out around the target size, just probabilistically, because you are seeking that point to branch on at a probability of 1 in 4 or 1 in branch factor. So you've got a target rather than an absolute. But that flexing has become an important property for our data structures, like the HAMT uses flexing a lot in a few different forms. But then you apply the same algorithm all the way up the tree. So you hash and index the entries in your next layer as well. And in the next layer, they're links to the base layer with a starting index so that you can traverse it later on. But you can run the same hash over that and do the same thing. And so you might end up also splitting at the next layer as well. So if you get this threshold below the threshold, then you branch again. And so you end up with multiple layers. And you just keep on running the algorithm until you get a single root. And then inserts mean you just run the algorithm again over the set, and they all, because they're stable, they all produce the same index, the same identity, and you still have the same breaks. So then new elements will either fit in the set or introduce new breaks. So here we've got one in the top there that's fitting in that set. So the mutation then is only that one path along the tree. Or the second one is where we're splitting a node into 2. And so again, probabilistically, 1 in branching factor, you will get a new split, introduce new nodes. And then the same thing for removal. And you can either remove elements like this one here that is just in the middle of a node, or you could remove a split, in which case you would be joining nodes. So these mutations don't always just affect one node and a path up the tree. They can also affect a neighbor. And as you think about the way that the tree works, this effect does compound as you go up the tree, because you're generating new data here because the CIDs change. So these things may shuffle a bit, but you're never in a situation where this is likely to propagate across the whole tree. Like, it's certainly not at the base layer, but there will be more mutation cost within the middle of the tree than with a HAMT or other data structure, but it's relatively minimal, and also within the probability of the branching factor you define. So this is the, what was this one illustrating? This is insertions that may cost you. This is a perverse case, so it's not, you could push this one to the extreme. So where we go from here, we insert B, and then we end up creating a new CID here, which has a break, and then the next one has a new CID because you've split it. Does that one work? Oh, you've inserted a thing here, and then you've created a new CID which is within the threshold. So in the second level, we've got these 3 nodes, and then you do the same thing here, and then you've got a break, and so you end up creating more levels here. But these, over time, within probabilities again, they sort of balance back to the right shape. Lookup operations are, this is just a B tree. Just go to the left. Go to the node that is lower than your index you're seeking. So lookup operations are cheap. Size operations are expensive, but I think I laid that out here. Insert, replace, remove mutations.
You can cache the size in the intermediary nodes.
Yeah, if you trust it. So lookup, insert, replace, remove, relatively cheap. And yeah, this given a sufficiently random hash function, nodes will bias towards the target branching factor. They will, within that sort of flex. And the randomness discourages thin trees. So the problem we have with the AMT is you can have these really thin trees because there's no way of biasing it towards thickness because you are brute force just using your indexes to define the shape of the tree, which is pretty gross. So it has this thickness property that's similar to a HAMT. And the big deal about this is it's canonical for any given data set. So even though it looks like they've got this random craziness going on, any given data set, regardless of intermediate removes or inserts, will form a canonical form with a canonical root CID, which is what we want. So that's that, but there is this one problem, which is that it's cheap to create collisions. Because the branching factor is just dividing the address space into that segment. It doesn't cost you much to craft entries that will be below the threshold to create a break or to not create a break. So in this instance, somebody could create a bunch of entries that don't break. And so you end up getting these really big nodes, which can break some systems. We do have limits on node size on that we can store in our storage systems or transport across transport layers. So we really do need to protect against this. So that's the really outstanding one. There's been a couple of solutions proposed so far for that. And I think Michael and McCullough are discussing through options.
Yeah, there's a bunch of ways to solve this, actually. It's just that these solutions are increasingly kind of complex the less you control the access patterns. So like if you just own the data structure, you can just insert tombstones into the structure whenever you see an overflow, and then it's becoming part of the canonical list, and so it's not actually out of hash or anything, right? It's still going to maintain a consistent hash. But if you don't like own the structure, or if you don't have some kind of consensus mechanism that says we're all going to apply these changes at once, then you can't really use that method. If everybody's applying the changes kind of in a different order, and then they need to come up with a particular structure, that becomes a little bit more difficult. Because you could end up with just the tombstones in different places depending on when you pulled it. Or a case that I have in DAGDB is like it's an index. So the canonical form is not actually the data structure, it's a view of a different data structure. And so you can't be inserting these tombstones, really. That means that it's really not the canonical form anymore. And so for that, you can use I have an algorithm for using like a floating fingerprint in order to calculate a sequence ID that you can use. Also, like if you get to hide something, like if you own the data structure and other people don't like manipulate it directly, you can just hide a nonce for the hashing, and then they can't generate these attacks because they can't predict what the hashes are going to be. So it's like really easy to fix if you have any kind of like agreed upon secret. But yeah. So yeah, there's a bunch of different ways to solve it depending on kind of what the access patterns are. It takes some work to figure out which one's going to work best.
All right, we are running out of time. We are over time. So yeah, so thanks for the presentation. Like that's interesting. Cool. Yeah. So then that's, oh God, then I'll see everyone next week. So goodbye, everyone.